Welcome to the deep dive. Today, we are plunging into a topic that, well, it touches all our lives waste, and we're exploring how one innovative approach is tackling it, sort of right at the intersection of environmental cleanup and climate solutions.
Yeah,
We've been digging into some really interesting source material from Vaulted Deep. And, our mission here is to cut through the complexity, help you understand what could be a game-changing technology.
hmm
We're going to unpack what this method is, how it actually works, and the potential benefits, some surprising ones for communities and the planet.
that's right. We're looking at how some companies are taking organic waste,
Hmm.
you know, stuff often seen as a major headache, and finding a way to put them permanently away deep underground.
Okay.
The materials we looked at really lay out the case for this. It builds on existing industrial practices, but applies them in a, frankly, quite novel way.
Okay, so let's back up. Before we get to the solution, let's really pin down the problem. We all know waste is an issue, but our sources highlight some particularly tricky challenges, especially with organic waste, things like manure and biosolids.
Right. Treated sewage sludge, essentially. And while these can be useful fertilizer sometimes, applying too much causes huge problems. Overload the land, and you get issues.
Like what kind of issues?
Well, you get nutrient runoff, polluting rivers, groundwater contamination, also significant air quality problems, and those persistent, really unpleasant odors that affect people living nearby.
And here's something the sources really shine a light on, and it's frankly quite worrying. Trace contaminants. We're talking things like PFAS chemical.
To forever chemical.
Exactly. They're found in biosolids, and the data is, well, it's pretty alarming. When these biosolids get spread on land, the PFAS can build up in the soil and water, levels up to 100 times higher than they started.
Yeah, 100 times. And this isn't some small niche problem either. The numbers are kind of staggering. Over half, 51% of all U.S. biosolids end up being land applied,
Wow.
and often with zero treatment for those PFA chemicals. Plus, you add nutrient pollution, often from excess manure, which affects something like 40% of rivers and streams across the U.S. So it's a big, widespread environmental challenge we're facing.
Okay, so faced with this massive problem, managing this difficult organic waste, the materials introduce a solution. And it sounds, I have to say, a bit wild at first. Inject it deep underground.
Right, that's Volted's core approach.
Yeah.
But it's not something they just pulled out of thin air.
No.
No, what's really interesting is they're not inventing a completely new wheel here. They're actually repurposing a technology that's been used for decades in the oil and gas industry.
Oh, okay.
It's called slurry injection. It was commercialized back in the 1980s, specifically for managing oil field waste. And it's been used safely, hundreds of sites globally since then.
Okay, proven tech. But how is Vaulted applying it differently? Because the sources seem to emphasize this is unique. Like, don't traditional injection methods need pure gases or liquids?
That's the key difference, yeah. This specific slurry tech allows for the permanent underground storage of solids mixed with liquids, the slurry.
Ah, solids. Okay.
That ability to handle solids is what's crucial for waste, like biosolids or manure, which just aren't pure liquids. It really opens the door to using underground storage for a whole new class of waste materials.
And they're sending it deep, right? Like really deep.
Oh, yeah. We're talking nearly a mile below the surface. The sources mention depths, often over 3,000 feet.
Wow.
They target these natural geological formations, the same kind of deep rock layers that have safely trapped things like oil and gas for, millions of years.
Right. So the geology itself acts as the container.
Exactly. The whole idea is that this waste gets sealed far, far below any drinking water sources. The materials show it's contained beneath these thick, impermeable rock layers. They specifically mention dense shale, which acts like a natural, super secure lid.
That geological containment sounds absolutely critical. But beyond just picking the right spot deep underground, how else do they ensure safety? Is the technology itself designed with safety built in?
Absolutely. The materials, they emphasize it's considered safe by design. For starters, they only accept non-hazardous waste. So no dangerous materials are going down there.
Okay, that's important.
And then there's constant vigilance. These sites are monitored 24/7 to make absolutely sure everything stays securely stored where it's meant to be.
And the well itself, the sources mentioned a specific design.
Yeah, it uses a very robust pipe-and-pipe design. And that structure is reinforced with cement, basically from the surface all the way down into that deep injection zone. It creates multiple barriers, multiple layers of protection for containment.
And this isn't just, the companies policing themselves. There's heavy regulation involved in the U.S., right?
Oh, definitely. Vaulted injection wells fall under the U.S. EPA's Underground Injection Control Program, the UIC program.
Okay.
That's part of the Safe Drinking Water Act. And its whole purpose is protecting underground sources of drinking water.
And getting a permit for that, I gather from the sources, is not easy. It's no cakewalk. They have to meet really strict federal standards.
Exactly right. You have to demonstrate through very detailed engineering plans, complex geological modeling, and continuous monitoring plans that your operations won't endanger water supplies. It's rigorous.
And then you do ongoing checks.
Yeah, plus, Vaulted adds another layer with their own proprietary monitoring software that checks the containment status in real time, basically every day.
Okay, one question that always seems to pop up with deep underground stuff, especially in some areas, is seismic activity, earthquakes. Does this cause them?
It's a really valid concern, and the sources address it head on. They point to a specific facility in Los Angeles, the tire facility. It's been using this exact same slurry injection technology safely for over 15 years.
In LA, that's a seismically active area.
Highly active. And the EPA has confirmed no seismic activity has ever been linked to its operations there.
Wow. Okay, that's a pretty strong data point. And do the materials explain why it's considered safe from a seismic perspective?
They do. They talk about rigorous seismic risk evaluation. When they choose a site, they actively avoid known, critically stressed fault systems. And, crucially, they inject into porous sedimentary rock formations.
Not like deep bedrock.
Exactly. Not into deep crystalline basement rock where you're more likely to induce seismic events if you inject fluids under pressure. Sedimentary rock is much less prone to that.
Gotcha. Okay. So we have this big waste problem, and we have this method proven safe, regulated to deal with it deep underground. What are the actual tangible benefits? What good does this do for communities, for the climate?
Well, the benefits are really multifaceted as the sources lay them out. First, and maybe the most immediate impact, is the direct environmental cleanup.
Oh, so.
By taking those pollutants, the excess nutrients, the PFAS, any pathogens, and locking them permanently underground, you prevent them from leaching into soil and water or causing air quality issues.
So straight up, improving public health, ecosystem health, by getting that stuff out of our immediate environment. And what about the odor issue we mentioned earlier? That's a big deal for communities.
It tackles that directly. The materials point out the waste is injected pretty much as soon as it arrives. It's not stockpiled and left sitting around to rot and smell.
Right.
In fact, by diverting waste that would otherwise rot, they can actually help reduce existing odor problems in an area.
And that huge concern, the PFAS chemicals.
This offers, according to the sources, a verifiable, safe, and crucially permanent way to isolate PFAS-contaminated waste. Since wastewater treatment often doesn't destroy PFAS, and land application just spreads it.
Putting it deep underground in secure geology is presented as a key solution.
Exactly. Getting those persistent chemicals out of the biosphere, away from people and ecosystems.
Okay, so beyond the cleanup, there are also significant climate benefits highlighted in the materials.
Yes, and this is a really key part. By locking away the organic carbon content of the waste deep underground, you achieve permanent carbon removal. It's sequestered, taken out of the atmospheric cycle.
And there's another climate win too, right? Avoiding methane.
That's a huge co-benefit. If this organic waste just decomposed above ground, like in a lagoon or even some landfills, it would release methane, which is, a really potent greenhouse gas.
Much more potent than CO2, short term.
Exactly. The sources estimate that, on average, every ton of waste they sequester permanently avoids about 5.8 tons of CO2 equivalent emissions over 20 years just by preventing that methane release.
And they can measure this.
They emphasize it's measurable. They use energy meters on equipment. They do carbon sampling of the waste streams for transparency and verification.
Okay, so environmental wins, climate action, those are huge. But the sources also talk about economic benefits for the communities where these facilities actually operate.
They do, yeah. Building and running these sites creates local jobs, and good jobs, apparently, with opportunities for upskilling. They mention office roles, field roles, often with strong wages and benefits.
And it's not just direct employment.
No, they also make payments to the landowners who host the wells. And they engage local businesses, trucking partners, equipment operators, that sort of thing, injecting money into the local economy.
They give an example, right, in Kansas.
Yeah, the Great Plains facility in Hutchinson, Kansas. That single facility, they say,
Huh?
created 25 jobs, and resulted in about $5 million invested into the community. And the sources note they're already upgrading it to take more waste and employ more people, so it's ongoing investment.
And they also mention addressing practical concerns like conducting traffic studies, working with officials to minimize disruption, and importantly, clarifying they only take excess manure, the stuff that really can't be used productively as fertilizer, so they're not competing with beneficial agricultural uses.
Yeah, that's a key point. All these pieces together paint a picture of a technology aiming to solve multiple problems at once.
So bringing this all back to you, our listener, what's the big picture here? What's the key takeaway? I mean, we've seen through this deep dive how one approach is tackling several really tough waste challenges simultaneously,
Hmm.
from nutrient pollution and nasty odors to those persistent PFAS chemicals. And it's doing it using proven technology repurposed in a, well, pretty clever way.
Right. And the payoff seems to be substantial wins for the environment, pollution prevention, and for the climate through verified carbon removal and avoided methane.
Yeah, and all while potentially boosting local economies through jobs and investment. Understanding this technology, it really gives you a window into how existing industrial methods can sometimes be adapted, maybe ingeniously, to solve completely different, really pressing problems.
It definitely highlights that potential for finding solutions in maybe unexpected places.
Exactly. It's a powerful illustration, isn't it? Taking stuff often seen just as a burden, a problem, this unusable organic waste, and using technology smartly to turn it into a multi-pronged solution. Safe disposal, pollution control, permanent carbon removal, and local economic activity.
So maybe here's a final thought for you to chew on as you continue your own deep dives. Given the just vast amounts of waste society produces and seeing the potential here for repurposing existing tech like deep injection, what other overlooked problems out there might actually hold the keys to surprising, impactful solutions? For our environmental challenges, our economic ones,
Mhm.
what other technologies, maybe from completely unrelated fields, could be adapted to solve something entirely new, something to think about?